Welcome to the AI Research Roundup. I am your host, Alex. Today, we're looking at syftr, Pareto-Optimal Generative AI, published May 26, 2025. This paper introduces syftr, a new framework designed to tackle the tricky business of building efficient retrieval augmented generation, or RAG, pipelines. Now, retrieval augmented generation pipelines are systems that help large language models by letting them pull in fresh information. This gets even more complex with agentic paradigms, which involve AIs that can plan and act more independently. syftr uses Bayesian optimization, a clever search technique, to find configurations that are Pareto-optimal, meaning they offer the best trade-offs, like between accuracy and cost. And for those interested in exploring this further, the code for this work is available on GitHub. The repository, also named syftr, provides an agent optimizer designed to help you discover the most effective agentic workflows that fit your specific budget. You'll find the syftr agent optimizer itself there, along with example notebooks and setup instructions to get you started. Alright, so this next figure gives us a look at what the paper calls a vanilla retrieval augmented generation flow. Think of this as a basic standard setup for these retrieval augmented generation systems we've been talking about. It's divided into two main phases, index time and query time. During index time, we start with a grounding corpus, which is essentially the collection of documents or data we want our AI to draw information from. This corpus then goes through a text splitter, which breaks down the text into manageable pieces, and there are various ways to do this, like by sentence or by using different chunk sizes. Then, at query time, when a user asks a question, that query is processed by an embedding model. An embedding model transforms the text query into a numerical representation or vector that captures its meaning. This vector is then used to search a vector database, which is a specialized database designed to store and efficiently search through these numerical text representations to find the most relevant pieces of information from our grounding corpus. This retrieved context, along with the original query, forms a prompt for the synthesizing LLM, which then generates the final response. And as you can see, at each step, from choosing the text splitter, the embedding model, the vector database, the prompt type, to the final LLM, there are tons of different options. Each combination leads to a unique pipeline with its own performance in terms of speed, accuracy, and cost. This really highlights the complexity syftr aims to manage. Okay, so here really visualizes the syftr system in action, designed to navigate that huge space of over 10 to the power of 23 unique retrieval augmented generation flows. At its core, syftr employs a multi-objective tree of Pareto estimators optimizer. Tree of Pareto estimators are a sophisticated statistical method used in Bayesian optimization, which help intelligently guide the search for the best pipeline configurations. This optimizer samples various flows, which are complete agentic retrieval augmented generation pipelines. You can see some of the many choices it considers. Different agent types like React, which stands for reason and act, allowing models to plan and execute tasks. Various LLMs such as GPT-4o, and different prompting strategies like chain of thought or CoT, which helps models show their reasoning. These flows are evaluated, and their performance on accuracy versus cost is plotted to identify Pareto-optimal solutions. These solutions form the Pareto frontier, that curve showing the best possible trade-offs. syftr also uses a Pareto pruner for early stopping, making this search more efficient by cutting off unpromising paths. Alright, so here really expands on that vast search space, showing us syftr's hierarchical approach. It starts with choosing from 5 top-level retrieval augmented generation flows, 1 non-agentic retrieval augmented generation flow, and 4 distinct agentic types: a sub-question retrieval augmented generation agent, a critique retrieval augmented generation agent, the React retrieval augmented generation agent we talked about, and something called a LATS retrieval augmented generation agent. These agentic flows then use the core retrieval augmented generation flow as a subroutine, which itself has many configurable parts, like the specific synthesizing LLM, re-ranker, retriever, or whether to use HYDE. HYDE, H-Y-D-E, stands for Hypothetical Document Embeddings, a method that generates a pseudo-document to aid retrieval. and each agentic flow adds its own unique settings on top, all contributing to that massive 10 to the power of 23 possible configurations. Now, to navigate this vast search space efficiently, syftr uses a Pareto pruner and illustrates its mechanism. We're looking at task accuracy plotted against cost. For a new retrieval augmented generation flow under evaluation, syftr estimates its performance not as a single point, but as a confidence interval, that pink shaded region you see. A confidence interval is a statistically estimated range indicating where the flow's true accuracy and cost likely lie based on initial evaluations. The blue step line represents the current Pareto frontier, showing the best trade-offs achieved so far. The pruner then looks at the most optimistic corner of this confidence interval for the new flow, its upper left point, which would represent potentially higher accuracy at a lower cost. If this best-case potential still doesn't surpass the existing Pareto frontier, the flow is terminated early. This early stopping, based on these confidence estimates, is crucial for syftr's efficiency. So, after all that efficient searching and pruning we just discussed with the Pareto pruner, shows us a concrete result, an actual Pareto frontier for retrieval augmented generation workflows, this time on the Infinite Bench dataset. Infinite Bench is a benchmark specifically designed to evaluate how well models understand and use information from very long documents. Once again, we have accuracy on the y-axis versus cost in cents per 100 calls on the x-axis, which is on a logarithmic scale here. The solid line represents the discovered Pareto-optimal solutions, those colored dots. Each dot is a specific retrieval augmented generation pipeline configuration that syftr identified as a top performer. We can see that syftr finds many configurations that significantly outperform the baseline, that white square, either by being more accurate at a similar cost or much cheaper for similar performance. Okay, so to get a better sense of the building blocks syftr is working with, Table A1 gives us a detailed look at the module choices and their search spaces for the core retrieval augmented generation workflow. For each module within a retrieval augmented generation pipeline, like the synthesizing LLM, the re-ranker, the embedding model, or the splitter, this table outlines the specific options syftr can choose from. For instance, for the splitter, which breaks down documents, it might pick a recursive, token, or sentence-based approach, each with tunable hyperparameters like chunk size. This detailed breakdown really underscores the complexity syftr manages. Alright, speaking of those modules, Table A3 zooms in on one specific type, the embedding model. We just saw in the previous table that the embedding model is a key component syftr can swap out. This table here simply lists the various embedding models that syftr has at its disposal. An embedding model essentially converts text into numerical representations, or vectors, that capture its meaning. This allows the system to compare the query with documents based on semantic similarity. We see options like BGE small, BGE large, GTE large, all mini LM, and several others. This variety of embedding models is another dimension in that vast search space syftr navigates. With all these different embedding models and other configurable modules, syftr clearly tackles a massive search problem to find those optimal retrieval augmented generation pipelines. The key takeaway here is that syftr provides a systematic way to navigate this complexity, automatically discovering configurations that give you the best accuracy for your budget, or the lowest cost for a desired performance level. This is incredibly valuable for anyone building practical and efficient generative AI applications. Well, that's all the time we have for today's AI Research Roundup. Thanks for tuning in, and I'm Alex, signing off.